Good afternoon, everyone. My name is Megan Polar, and I am the president of the Nz Ssa Christchurch. I would like to thank you all so much for coming this afternoon to our very first event. We're super excited that we are now finally getting everything underway. So let's get this started. Just a few house rules. So the exits are there and the one that you came through. And in case of emergency, please exit the building in an orderly fashion, and the collection points are just out around there, and there should be like marshals there. A little bit about Nz Ssa. So the Nz Ssa is a national student-run organization that was founded in Wellington last year by a core team of students at Victoria. My two good friends and I, Anushka and Ayushi, met them last year at the Erasmus conference, and were inspired by their vision, and so opened our own branch here in Christchurch this year. We were concerned that there were no student-accessible astronomy or space science clubs at the university or in Christchurch, and kind of like in New Zealand itself, because Christchurch is such a rich and vibrant place for space science and technology. And this concern had been with us for quite some time. As high school students, we found that there were very few permanent opportunities for those passionate about astronomy. So we were determined to change that in quite a big way. And so here we are now. The Nz Ssa is a student-run and led non-profit organization that seeks to inspire students of all ages in the space industry and astronomy, and then support them on their journey to have careers in this field. However, we also want to inspire this interest in the wider community and show that the space industry is a multidisciplinary and an exciting and viable option for New Zealand. And so I would like to reintroduce Ayushi and Anushka, my co-founders and vice presidents, and the rest of the execs. We have quite a few people here. We have Seth, general exec. We have Thomas, our social media officer. We have Ben, our tech officer, who is manning the camera. We have Finlay, who is our external outreach manager. And I think that's all we have today, but we have several others. Oh wait, no, and we have Diane, our treasurer. So stop talking, and I'll introduce our lovely speaker here for this afternoon. Dr. Sarah Kessans is a plant biologist and biochemist who is currently a postgraduate fellow here at UC and an aspiring astronaut. So please welcome Sarah.
Thanks very much, Megan, and thanks on behalf of all the exec. It's really exciting to be here. I wasn't meant to be the first speaker, so it's with a little bit of a heavy heart that I am the first speaker, and the reasons why I am here today, and why you guys didn't have an event last week. I hope you guys are all doing well in light of everything last Friday, and hope your friends and family are doing well as well. But like I said, I'm really, really excited to be here, and really excited to see the New Zealand Student Space Association get a chapter started here in Christchurch. Christchurch has been my home for the last 6 years, and I've started to see the different student organizations, especially the chapter in Wellington, get started and get that excitement growing. And I've seen what it's done for all of the students that are interested in space and astronomy there in Wellington. So I'm really excited to see what you guys can do here in Christchurch, and I'm really excited to be a part of it. And so, like I said, thank you very much for having me come and speak with you guys today, and hopefully I can inspire you a little bit more. I think you guys are all pretty excited about space and things like that here in Christchurch already. But hopefully by the end of this talk, you're even more inspired. So just a little bit about my background and where I come from, because a lot of times you see scientists and researchers, and they're up there, and they look like they've had this amazing career, and it's just a straight shot, and of course they've been successful the whole time. Oftentimes that's not the case, and for me that wasn't necessarily the case either. So I, as you may or may not be able to tell from my accent, my parents think I have a Kiwi accent, but I am not originally Kiwi. So I was born in the U.S. I grew up in the Midwest in Indiana, landlocked area, rural area, grew up on a farm. But I had some amazing teachers in middle school and high school that really got me interested in science. So I already had sort of an interest in science, but they really took my interest and made sure that I could get into really good science classes and sort of use that passion for something bigger. And so I got into science research as a high school student. So I grew up on a farm, and I was really interested in plants in general. And so I started a science fair project when I was in 8th grade, so when I was 13 years old, looking at tannins in oak trees, and actually was able to create a natural herbicide, which obviously leads right into becoming an astronaut, right? Not exactly the prerequisites for becoming an astronaut, but really passionate about science, really passionate about learning more about the natural world. And so I took that passion for science and science fair and science research in high school and went to Purdue University, which is a couple hours from where I grew up. So it's very much an engineering school. So we're the cradle of astronauts. We've graduated 23 astronauts. And I went into the School of Agriculture at Purdue University and studied plant biology. I was really grateful to be able to get into a research lab my first year. So if any of you guys are undergrads and have the opportunity to get involved in a research lab, that really changed the course of my career, getting to get involved with research as an undergraduate. So during my undergraduate days, I studied plant biology. I was working on some research projects on cell wall biosynthesis, which can make stronger corn, and now it has some implications in biofuels. But it wasn't really fueling my passion for using science to help the greater good. And sort of what I wanted to do was use my science to create a solution to one of the world's biggest problems. So I took that passion. I had a couple internships, both at the Weizmann Institute of Science in Rehovot, Israel, and then at the University College of Dublin in Dublin, both sort of plant-based internships as well. So I had lots of experience in science, but I knew I wanted to do something bigger. So I went to Arizona State University, where they have an amazing program on plant-based vaccines. How many of you guys have heard of plant-based vaccines? Yeah, one or two. I hadn't heard of plant-based vaccines prior to going to Arizona State either, but it really sort of combined my passion of science and helping to sort of solve one of the greatest problems out there. So I was working on an HIV vaccine for my PhD at Arizona State University, and really got me interested in natural products and how we can use sort of the natural world to create these solutions. And that sort of brought me here to UC in a long, windy way, so very windy geography, and then sort of from plant biology into more of a biochemistry role. And here in New Zealand, as you guys might know, we've got some incredible fungi out there. They're beautiful colored fungi, so the colors are natural products, but those fungi also make other products like antibiotics and insecticides and anti-cancer agents. And those are some of the things that I've been working on for the last couple years, is looking at biosynthetic pathways in fungi. It's a similar mold to the mold that grows on your bread that makes bread not taste very good and turns it green. Those actually produce a lot of really cool chemicals that we're turning into antibiotics and insecticides and anti-cancer agents. So that's sort of my scientific career. Science is one of my big passions. But then another one of my passions is adventure and team sports, and just basically getting out there and working hard physically as well as working hard mentally. So I was at Purdue University. I walked onto the rowing team. So how many of you guys have ever rowed? Yeah, pretty tough sport, both mentally and physically. And prior to my undergraduate career, I had never rowed a stroke in my life. I'd played basketball and softball and lots of different sports. Never rowed before, but absolutely fell in love with the sport of rowing at Purdue. And after Purdue, I knew I wanted to continue rowing. And so most people, that means rowing as, as a club member, rowing you can still row competitively, but not to the elite level that you're working at as a collegiate athlete. Or you can go on to the Olympics, and I was a bit short, so I wasn't going to be able to go into the Olympics. So naturally, I decided to row across the Atlantic Ocean. So the woman in the up the top right, Emily Cole, was actually one of my competitors. So we were on the same team, but we were in different boats. And we were definitely not friends before we decided to row across an ocean together. But after you decide to row across an ocean with each other, you definitely become friends. So out of the 115 members of my rowing team at Purdue, Emily was the only one that really wanted to do this with me. So we were 21 and 22 years old at the time, so basically your guys' age. How many of you would row across the Atlantic Ocean? Yeah, a couple. Good, excellent, very good. I've got some crazies in the room as well. So basically, I read a book on ocean rowing, and that sort of inspired me to do this, and Emily wanted to do this as well. So this was in 2005, and if you guys remember 2005, you may or may not, that was the year of Hurricane Katrina, Hurricane Rita. So this should be a fully self-supported, human-powered 5,000-kilometer race across the Atlantic Ocean in 8-meter-long ocean rowing boats, right? Fully self-supporting from the Canary Islands off the coast of Morocco to Antigua in the West Indies. 5,000 kilometers in this boat. Basically, you've got all your food on board, you've got solar panels that feed marine batteries, that power your water maker, that desalinate your ocean water, your GPS to get you across, everything that you need to get across. And we're starting in December of 2005. This should be well after hurricane season has ended. And unfortunately, in 2005 and 2006, that was not the case. So we got about halfway across, and we had 10-meter waves. We had 30-knot winds for 2 weeks while we were out there. So at the end of those 2 weeks, we were sitting on sea anchor, which is like a big parachute that deploys underwater. We had been sitting on that sea anchor for about 18 hours, and we got hit by a rogue wave, so a giant wave, much larger than the 10-meter waves that were normally hitting us, flipped us upside down. We were 1,400 miles from the nearest dry land in 10-meter waves. That's what we looked like on our upside-down boat for 16 and a half hours, not knowing if we were going to be rescued or not. It's quite a long journey, and that I give a full different lecture on that part of the story, but that's not why we're here today. I'm just sort of setting up the story. So obviously the first time didn't go so well, but if at first you don't succeed, find some teammates to do it again, right? So we came back as Team Unfinished Business 2 years later in 2007. So it was myself and Emily Cole, my original teammate, as well as Tara Remington, who was on a pairs boat, who flipped basically 8 hours before we did in the same tropical storm. Her partner Ian wanted nothing to do with ocean rowing anymore, and fair enough. And then Joe Davies, so Tara's from Auckland, and then Joe Davies is from the UK. She was on a fours boat in 2005 and hurt her back and had to get taken off the boat. So we came back as Team Unfinished Business. Had a much better row the second time around. Had a 51-day crossing, which we set a world record by 17 days. The previous record was 68 days. So much better row at the second time. Like I said, there's lots more stories to this, but I'm just, like I said, I'm setting up where I've been for the rest of the talk. So just absolutely incredible feeling to get to the finish line, to have a big hug and to have finished what we set out to do 4 years prior. And Tara also taught us a haka at the end of the row. I'm not quite sure how well we did with it, but it was 2 in the morning landing, and so the crowd was quite enthusiastic with our sort of makeshift haka. It's hard to learn the haka when you're on a rowing boat and you can't actually stand up. But anyways, point being is that, you know, we were trying something, we failed the first time, we tried it again, we succeeded. And that's sort of how my life has gone, and I don't know if that's sort of how your life has gone. You know, there's a lot of things that you do and that you try and they don't quite go as well. But sort of throughout all of my life, the two pillars, I guess, of my passions are science and adventure. And both of which take a lot of teamwork, take a lot of exploration, take a lot of passion and hard work and persistence, because these are things that are not easy. How many of you guys are involved in science or engineering? Yes. Is it easy? You do it because it's easy, right? But like I said, these are my passions, and hopefully they're your passions as well. And basically, you want to keep doing them because you love them, right? But anyway, these are two things that I really love, and it's great to have a science career, and it's great to have the adventure, but I really wanted to combine them into one career. And what sort of career do you think we can find that combines both science and adventure? Space travel, absolutely. So like I said, I went to Purdue University, which, like I said, we've graduated 23 astronauts. And so I have a lot of really good friends that work for NASA in the aerospace industry. And of course, they're on Facebook. And so I was literally eating my Weet-Bix one morning, flipping through Facebook, as you do, when my good friend who works at the Kennedy Space Center, she's an engineer for one of their launch teams there, posted that NASA was looking for its next class of astronauts. I was like, that's nice. And she had posted a link to the NASA Tumblr account, and I was like, I'll just click on that. And there's this Tumblr that had lots of pictures and basically these 5 signs that you might be ready to apply to become an astronaut. And the first one was you don't mind roommates, and it had a picture of the team on space station eating dinner together, and I was like, that looks like fun. The second one was you love space, and I was like, well, yes, I already love space anyways. I was a kid growing up in the shuttle era in the States, and every little kid wants to be an astronaut, so yes, I love space. And it had a picture of an astronaut in the cupola. Have you guys seen pictures of the cupola on the space station? Looking down at the Earth, and just one of the most inspiring pictures. Third one was adventure doesn't scare you, and I was like, yep, I've had a little bit of adventure in my life, okay. You want to be on the cutting edge of science, and yes, that's my other passion, we're good there. And you're not afraid of heights. And I wouldn't say I'm fearless with heights. I do a little bit of climbing, but in general, I wasn't afraid of heights. I was like, that sounds good. I fit those criteria. I looked up the application materials, and I realized that I fit all the basic criteria, which were to be a U.S. Citizen, to have a bachelor's degree in science, engineering, technology, or math, and have 3 years of experience post your degree. And that was pretty much, that's the basic requirements. I was like, well, I fit that. So as you do, I put my Weet-Bix aside and started the application to become an astronaut. So this was in February of 2016 is when the application closed. And so just to get that email was pretty amazing. I mean, how many of you guys have ever applied to be an astronaut? That was, I never knew this was a possibility, right? As a plant biologist, biochemist, I didn't know this was a thing that you could do. But I did it, and it was great. And I felt sort of confident. I was like, I've got a good application in, and we'll see what happens. And then the application closed, and the next day, NASA had a press release saying how many astronaut candidates had applied. And in the shuttle era, there were about 7,000 per application cycle, 7,000 applicants per application cycle. Anybody want to take a guess as to how many applications were this cycle? How many? 7,000? That sounds like a good guess, right? So the shuttle era, there's lots of people wanting to go. Is NASA even sending astronauts to space right now? We don't have a shuttle. What can we do? 18,300 applicants. I was like, well, I love New Zealand. I love what I'm doing. I really enjoy being at UC. I'll probably be here because out of 18,000 applicants, they're not even going to see my application. But I was a member of a couple astronaut hopeful forums, and so I knew generally what the timeline for the process was supposed to be. So the application opened in December. It closed in February. We knew sort of May to July time frame. By July, things would start becoming more public as to where the selection process was at. And so in July, we sort of knew if you were going to go on to the next selection round, you would start having your references start being contacted. So basically there are 5 references on your application, so 5 people that you wanted NASA to tell NASA good things about you. And so you knew sort of in July, if your references were contacted, that you'd made it to what they call the highly qualified pool, which is the top 450, right? Which is pretty incredible. Out of 18,000, to make it to the top 450 would have been just an absolutely amazing thing. And so you try not to think too much about it. And so there's one day, I'm sitting there at my desk, and my postdoc advisor got an email from NASA and forwarded it to me, and she said, "Is this a good sign?" And I was, "Yes, let me check my other 4 references." And so checked with my other 4 references, and sure enough, all 5 of them had received emails from NASA asking some information about me. And I was like, that's just beyond my wildest dreams to have made it into this highly qualified pool. So again, out of 18,000 applicants, not only did they see my application, they liked it. And I was like, it was just absolutely amazing. And just a little bit of sort of crazy trivia. I had a good friend in geology. She was a lecturer in geology, and one of my whitewater kayaking buddies, she had also applied to become an astronaut, and she also made it into the highly qualified pool. So there were 2 of us here at UC that had made it into NASA's highly qualified pool for the astronaut selection for 2017. So that was pretty cool. What was even cooler was a month later, I got a call from the astronaut selection office, which is just insane, just to get a call from the astronaut selection office. And so the woman on the end of the line said, "Yes, we'd like to invite you to NASA for initial interviews." And of course, you try to be professional and talking about the dates, and yes, I can make those dates whenever works just fine. And of course, very professional on the phone, and they hang up the phone. I was the only one in the office, and I'm just jumping all over the office. And the people in the office next door thought there had been an earthquake because I was just so excited. So that was pretty incredible to be invited for an initial interview at the Johnson Space Center. So the first interview is 3 days long. So you get to go to the Johnson Space Center. I can't actually tell you what we did, but it was an incredible 3 days with lots of challenges, mentally, physically, psychologically. They test you. But more than the sort of official things that we got to do was just interacting with the people. UC is an incredible community, but NASA is just something else, just incredibly intelligent, passionate people that are working for something greater than themselves. And it was just really inspiring to be a part of that community, even if it was only for 3 days. Have any of you guys ever been to either the Johnson Space Center or Kennedy Space Center? Have you seen the Saturn V rocket? How awe-inspiring is that? It is just one of the most amazing things. I mean, it's almost 400 feet long. It takes minutes to walk from one end to the other, from these massive engines all the way down to the tippy top, which is where astronauts sit on top of a giant bomb, right? It really sort of brings everything into perspective of this is the job that you're signing up for. You are signing up to be on that tippy top of the rocket going into space. And so I knew I had wanted to be an astronaut before then, but that 3 days basically solidified that this is what I've wanted to do for my whole life, and I want really nothing else other than to be an astronaut. So we got to tour the facilities. So we got to pretend like we're actually astronauts in mock-ups of the space station and the international, the space station, as well as the space shuttles. Got to go to mission control, and that's Kate Rubens, who's one of my heroes. She's a microbiologist, and so she brought her pipettes up during this mission, and as a biochemist and molecular biologist, it was just the coolest thing to get to watch her do her work on station. And then got to sit in T-38 jet as well, which is the training jet that NASA uses to train their astronauts. How many of you guys fly? Like, are pilots, or maybe taking lessons, or want to be a pilot, or just think jets are cool because that's the coolest thing? That was one of the highlights of that. That wasn't even an official part of the interview. It was just we got to sit in the jets, and just, again, these little kid dreams come flooding back. So anyway, came back to Canterbury. It's kind of hard to focus on the research when all I really wanted to do was become an astronaut. But that was the initial interviews were the top 120 applicants. And we knew the next selection cycle was going to be 50. So they're going to take 50 out of the original 120. So again, you start to do the math, and you're like, I'm not going to get excited because I'm probably not going to make it, and I probably screwed a lot of things up during that interview. So glad my research is going well. Glad I love the team here, because I don't want to get my hopes up. And so I was getting ready to bike to work in December of that year, of 2016, and I missed a call from the selection office. So of course, you put everything down and call them back, and it was the selection office again, and they invited me back to Houston for the finalist interview. So this is the last stage that you can get before you become an astronaut, the top 50. This is the finalist interview. So I got to go back to the Johnson Space Center in early 2017. This was 7 days of interviews. Again, one of the most challenging times of my life, and I've been through a lot of things. But again, just so meaningful to be there. And really, at this point, it was to interact with the other interviewees was really, really special. Because these are people that are at the top of their game, that have these amazing stories. You know, they're doctors without borders in Africa. They're pilots that have flown in Afghanistan. They're physicists that are changing the world of physics. And they're just the most easygoing, normal people that you wouldn't think are the top of their field. They're just really humble, amazing people. And just to be a part of that and to work with them over those 7 days was just phenomenal. So again, I came back to Canterbury. Really hard to focus on my research. Again, I've got some phenomenal friends, some phenomenal teams here, but it was really hard to focus on anything other than becoming an astronaut. And this was for a couple months. Sort of had to let all the other interviews get done and have the selection committee make their choices, which, again, I wouldn't want to be on the selection committee because it would have been so difficult to choose from that 50 down to 8 to 14 candidates. But they did have to make a choice, and I got a phone call. Like I said, a couple months later, I knew the phone call was coming. It came a little bit earlier in the morning than I had hoped it was going to, the time difference with the States. And how many of you guys have read astronaut biographies? Yeah, so most astronauts don't get in their first try. So if you read astronaut biographies, you know how the call is going to go, yes or no. It's going to change your life either way. If it's yes, best day ever of your entire life. If it's no, you're going to sit at home with cookies and just cry, which is what I did. Yeah, got the call, and a little bit of small talk and how's your day going, and that's sort of going to depend on what you say next. And the person on the other end of the line goes, well, unfortunately, and then my whole, but that's what you do. You get through it, and I was so proud of the class. Like I said, they could have picked any of those 50 people, and it would have been a phenomenal class. And so I'm really honored to know and call for these people, some of my good friends, and it's been phenomenal to watch them go through their training. So they started their training in August of 2017, and so they'll graduate as astronaut candidates this coming August. So they're almost done with their training, so it's really cool to be able to watch them become fully fledged astronauts, even if I'm not there, and even if I'm not part of that team. Like I said, it's been really awesome to have the support of everybody at Canterbury and really all of New Zealand as I went through the process, and it's been really cool to watch them go through their training as well. And so I was able to get feedback on the process, and I was highly encouraged to apply again. So there will be another selection coming up probably at the end of this year, and so I'll definitely be applying for that. But this isn't why we're here. So that's my story. What I sort of want to convey to you guys is some of the things that I've learned that hopefully can help you, and what we're doing in Christchurch and New Zealand in general, and how you guys can be a part of that. So some of the lessons that I've learned sort of throughout my life, but very much so throughout the process of the astronaut selection, was feel the fear and do it anyways, right? How many of you guys have done something that really scares you? How good did it feel getting through that and coming out the other side and just, having that in you, in your character, and knowing that you're capable of that, right? How many of you guys would consider yourselves nerds? You can raise your hand. It's a safe place, right? I absolutely consider myself a nerd, and I wouldn't say outcast, but I've never really fit into, the cool group, right? I've absolutely never been cool. I will never be cool. And you know, it's hard being different. It's hard pursuing things that aren't the normal things. But that's absolutely what's made me who I am. And I guarantee that's been a part of the astronaut selection, is that I'm different, right? There's a lot of engineers out there. There's a lot of scientists out there. There's a lot of adventurers out there. There's not any one person that has the skill set that I do. And there's not any one person out there that has the skill set that you guys do. And that's what makes you special, and that's what makes you strong and capable as a scientist, as an engineer, as anybody in humanity, really. So don't let the fear stop you from doing what you want to do, right? So fear of the unknown or being different shouldn't dictate your choices, right? If you've got passion, if you've got purpose, if you've got persistence, anything really is possible. And one of the lessons that's really become apparent in the last week, you know, what is the most important thing in the world? He tangata, he tangata, he tangata. It is the people, it is the people, it is the people. People are our greatest resources. And the more I get into the aerospace community here in Christchurch in New Zealand, we've got so many amazing people. And what makes NASA so great is its diverse set of people, its diverse skills, its diverse personalities. For the astronaut corps, they weren't just looking for scientists or engineers or physicians. They were looking for all of these people. They weren't looking for extroverts or introverts. They were looking for a mix of skills. And as we move to diversify the whole space economy, just beyond the astronaut corps, obviously, we need, obviously, scientists, engineers, physicians, pilots. We also need economists. We need lawyers. That's a big one in New Zealand, is developing space policy. Humanities, how does this fit into to us as a world, as humanity itself? So those are lessons I've learned, but obviously NASA's looking for astronauts. New Zealand's not quite looking for astronauts. How many of you guys would love to be an astronaut? Good, I'll tell the space agency. That's something that we're absolutely working towards, and I do firmly believe in our lifetimes we will have Kiwi astronauts. So whatever you're doing right now, keep striving. Keep that dream in the back of your mind, because eventually we will have opportunities for Kiwis to get into space. But until then, what we're trying to do here in Christchurch is develop a really diverse space economy. And UC fits in that, and I think all three ways, but very much so in both the research and the education side of things. So I've named a few things in here that we've already started developing as our sort of ecosystem here in Christchurch. How many of you guys are engineers? Scientists? If you're in school, like are you studying? I mean, you don't have to be practicing engineering, but if you consider yourself an engineer or a scientist, yeah. Anybody in biology? Yes, very good. Physics, maths, astronomy? Yeah, excellent. Yeah, so obviously we need all those things. Is there anybody for law or economics? Yeah, no, wicked. Humanities? And that's the thing, we need all these people. We need all of you to create this economy, right? And then we're developing industry here in Christchurch as well, which I'll talk a little bit about in a second. But like I said, as we develop this economy, we're going to need the research side of things, the education side of things, and the industry side of things. And that's what we're trying to develop here in Christchurch now. Like I said, what I'm really passionate about, and so those of you guys that raised your hand with biology, I'm hoping you guys will help me out, because I need to develop a core here in Christchurch. Like I said, I'm really, really interested in the biological aspects of space exploration, so in situ resource utilization. So how can we use limited organic materials to grow biomass for food, for fuel, for pharmaceuticals, for building materials? So how many of you guys have seen The Martian? Yeah, pretty much. Between this first one and then the second one, biological waste recovery. On station, one of their mantras is, we turn yesterday's coffee into tomorrow's coffee. You can use your imagination as to how that works. What I would like to do as a research scientist is turn yesterday's curry into tomorrow's curry. Right, and don't think about too much how we do that. Organic resources, right? And so I consider myself a synthetic biologist now. So like I said, a lot of the work that I do is on fungi, which can grow quite easily in microgravity. And like I said, they produce a lot of really cool secondary metabolites. So some of the organisms that I'm looking at now are yeast, cyanobacteria, filamentous fungi, which is sort of my favorite at the moment, using different genomics resources and tools and bioengineering strategies to develop organisms that can create food and fuel and medicine. So this is some of my fungi down here. Like I said, my pet projects that produce some really cool things. And the bottom is sort of my first love. Do you guys know what kind of sprout that is? Any guess? You want to take a guess? So this was growing in my garden when I got back from Houston. So it's a little potato sprout. So if you guys have seen The Martian, hey there, little guy. Anyways, then another thing that we're exploring right now, I don't know if any non-biologists will think this is cool, but protein crystallography, which is a big industry here on Earth for developing pharmaceuticals and understanding protein structures. We can do that really easily in space, and so that's one of the projects that I'm working on right now as well. But back to Christchurch. So as part of this, there's a space research steering group here at UC. There's also some organizations that I'll talk about here in a second. What we're trying to do is develop a whole ecosystem and a whole strategy for aerospace in Christchurch. So right now what we're really looking at is what are our current strengths, and we've got a lot of them within industry and within UC for research and education, and then really looking at future capabilities, right? So we've got Rocket Lab. How can we use what we have now to develop something that's going to be relevant in the next 20, 30 years? So we're looking to what we call skate to where the puck is going to be, right? We don't want the rest of the world to basically, we don't want to fall behind the rest of the world. We're trying to see what's going to be hot in the next couple decades, and what's going to attract people and investment to Christchurch. And then how do we all work together within industry, within research, within education to develop this ecosystem. So we've got a lot of great organizations that are working on that here in Christchurch. So we do have a New Zealand Space Agency. How many of you guys knew that? Good. So this was developed in 2016, and we're still trying to develop, and I say we, this is a global we, developing a strategy for New Zealand Space Agency. So what's really cool about this being a fairly young program is you guys are going to get to help develop this as well. As part of students, as part of the greater ecosystem, you guys are going to get to have a say in this, which is really cool. And so that's sort of New Zealand-wide. And then we're really special here in Christchurch. We have this Christchurch Aerospace Center, which we're developing a strategy for Christchurch. So we're working with UC, we're working with industry, and we're working with basically the entire community here in Christchurch to develop a strategy for aerospace in Christchurch. How many of you guys knew we have about a couple dozen industries in Christchurch that are currently working on aerospace projects? So I was not going to talk about individual companies today because that would take quite a long time. But there's several companies that are already working with NASA that already have pieces on station, already have pieces in rockets that are working with Rocket Lab, some of the commercial partners in the States. So we've already got a really developed industry in Christchurch. We're just trying to bring everybody together. So that's what the Christchurch Aerospace Center does. We've got meetups about once a month. Those are really handy for networking and seeing what's going on in Christchurch. So if you go to that website there, christchurch.space, it'll talk about some of the next events that we've got going on. There's also another directory called spacebase.co. And that's a directory, again, a New Zealand directory of all the different industries and organizations and partnerships for the New Zealand aerospace industry. And I can definitely make these available later as well. And then how many of you guys have heard about the New Zealand Aerospace Challenge? Sweet. So there's a challenge last year, and there's another one that just opened up, and we will have a road show in early April. I'm not sure on the date of that just yet. This challenge is looking to develop strategies for looking at both water and soil pollution using drone and satellite technology. And this is open to anybody. So if you guys have some ideas and want to put in a project for the New Zealand Aerospace Challenge, that's something that's really cool as well. But what's UC specifically doing? So like I said, we've just recently developed a steering group to look at some of the different research that we have going on. These are some of the members of that steering group. And these are some of the people that already have research going for aerospace here in Canterbury. So Alan Scott is doing some really cool, how many of you guys know Alan? Yeah. So it's doing some really cool work developing building materials with regolith. So that's really fun. Chris Hahn, do you guys know Chris Hahn? Doing some rocketry work. And then we've got, like I said, researchers all over both engineering and science that are doing some phenomenal work. And what we're trying to do is bring everybody together to develop sort of a cohesive strategy. We also have an amazing student group. In addition to the Student Space Association, we have the UC Aerospace Club, who's launching some rockets here in New Zealand, and we'll be going over to Australia in April to launch this little rocket here called Into the Blue. And this rocket, about a month and a half ago, carried the first biological experiments not into orbit, but on a rocket. So launched on a rocket and recovered here in New Zealand. That was the first biological experiment. So we had some pine cells and some yeast for making beer. But that's a student-run club, right? So it's pretty impressive that we're doing these sort of things as a UC community, both researchers in the labs and then students as well. And like I said, really excited to have you guys opening up this Christchurch branch of the Student Space Association. So that is me, and I'm just going to end with one of my favorite quotes that sort of encapsulates everything that I sort of talked about today. Just talking about passion. So don't ask yourself what the world needs. Ask yourself what makes you come alive, and then go do that. Because what the world needs is people who have come alive. Thanks, guys. And I am more than happy to take all the questions you guys want to throw at me. Yes?
If you do manage to get into space, what's some experiments that you'd like to see happen up there?
Oh, man. I could go on and on about this. So what are some of the experiments that I would like to see up in space? From a selfish standpoint, it'd be really amazing to get some of my fungi that I've developed here on Earth up there. But for me, the biological and the life support systems are the most interesting because we really don't know a whole lot about how organisms grow in space. Obviously, it's a completely foreign environment, and we've really only been on station for less than 20 years. And that's not a lot of time to try to understand how things develop and grow in microgravity. And eventually, we will be a multiplanetary species. Eventually, Earth is not going to be our only home, which is just a crazy thing to think about. But there's a lot that we have to do to get there. And for me, the most exciting things are understanding how microbes work in space, understanding how they produce these secondary metabolites, how can we grow food, how can we recover biological material. So those are the most interesting ones for me. And we do, and I say the royal we, I'm not part of NASA. NASA does quite a few biological experiments already, but I'd like to see more in sort of trying to understand sort of life support systems and how we grow things in space. Yes?
Would you consider working at NASA just to provide your scientific expertise to them? For example, as we said, we will be a multiplanetary species, so obviously they're going to need all the experts that we can get on topics of terraformation and stuff like that. So would you consider doing that?
Yes, I would absolutely consider working for NASA in some sort of capacity that's not an astronaut, just because they're an amazing organization that I really respect. And just the team aspect of it is just phenomenal. But even beyond that, I'd like to create that here in New Zealand. And I think it's absolutely possible. I think we have the capability and we have the people that are passionate and intelligent that are able to do this. So even more than working for NASA, which would be an absolute dream come true, what I'm trying to do now is develop that here in New Zealand. Yes, Megan.
Back to the experiments on the ISS. Like, how long have the biological experiments on the space station been running for? Have they been running for the full 20 years? Or?
Yes, so there have been lots of biological experiments sort of since the space station had experimental, labs up there, had modules for experiments. And obviously they've been doing experiments on the astronauts themselves. So we've learned a lot in the last couple decades. So the first astronauts that had long duration missions had quite a bit of trouble with, of course it's Jan. So had quite a bit of trouble with muscle atrophy. So if basically your body is very efficient and it's use it or lose it, right? So if you're not working your muscles, which you don't in microgravity, you lose your muscles. And so you come back to Earth and you know, it's very difficult to do things because you basically have no muscles. And the same goes with your bones as well. It's amazing how quickly your bones will atrophy because your body can use the minerals in your bones for other things if it's not using it to support your body. So those were experiments that they understood were happening. And now we've developed solutions for those things. So, we've got a weight machine up there, we've got a treadmill up there that can basically mitigate some of those ill effects of microgravity. So those experiments have been going on basically from the get-go. And again, this is all the royal we, as they go through, through the decades, the experiments have gotten more sophisticated and more PIs are getting involved, which is really exciting. But it's also really difficult as an astronaut because now you have hundreds of experiments that you're doing a day. But we've been able to learn a lot, and it's really cool to see. Yes?
So obviously at the moment, we're kind of confined to low Earth orbit with the ISS. I'm just wondering if you had the opportunity to go further afield, like to the Moon or Mars, would you want to?
Absolutely, and this is a question that we sort of threw around amongst ourselves as interviewees. So if you had the option of either landing on the moon, so you're not going to be the first, but you get to land on the moon, or you go on a Martian flyby. So you don't get to land on Mars, but you get to be one of the first to go around Mars. What would you do? And it's a hard one. And it's really difficult. I mean, to be able to land on the moon would just be an amazing feeling. But can you imagine getting to go to Mars and be one of the first humans to see it with your own eyes, but then not be able to land on it? So that was a tough call for us, and it was sort of split. I'm not going to necessarily tell you my answer, but the big thing was that if you're going to the Mars or you're going anywhere, we all wanted to come back because happiness isn't real until you share it, right? And so getting to go and see these amazing things and then just dying on Mars wouldn't be that much fun. But getting to be able to bring that inspiration and bring that knowledge back would just be one of, that just amazing for humanity. So yes, I'd want to go, but yes, I'd also want to come back. How many of you guys would go? How many of you guys would land on the moon? How many of you guys would go to Martian flyby? It's a longer trip. It's more fun. You get to hang out more, right? I would go around Mars because I think, and then on the way back we just land on the moon just real quickly. Yes.
What are the terraform applications of what has been researched on the moon, on the space station biologically so far?
As in terraforming Mars, or just
What are the
yeah.
What are the current applications that can be used on Earth from what we've learned from the biological experiments that have been conducted so far?
Absolutely, so much. Pretty much everything that we're doing on station have parallels to what we're doing on Earth. So we're, let's just say they're looking at heart cells, right? How heart cells respond to microgravity. The more we learn about heart cells in general, the more we can apply it to heart disease on Earth. And again, for me, sort of being a synthetic biologist and trying to utilize microbes and the small resources as possible, trying to grow things on space, you have to be pretty much 100% efficient. And so that has parallels to farming and producing food and things here on Earth. So pretty much everything that we do has a parallel on Earth. It's still life. We haven't created new life that has, that works completely differently than the way life works on Earth. So it's absolutely, it's important for both space research, but then also for life on Earth. Yeah.
How do you, this is kind of life advice question, I guess.
No, that's good.
How do you sort of combat the feeling of being like too late? Like I missed my opportunity to start getting qualified, to start the process to become an astronaut or
Yeah.
whatever else you might choose to be?
That's an excellent question, because I think a lot of us have that. It's like, you're like, oh, I wish I would have known about that 30 years ago. But I would say it's never too late, right? So I am a plant biologist and a biochemist. Who would have thought that I would be competitive in an astronaut field, right? I know him. Thanks, GJ. Thanks for the support. But point being is, don't discount yourself. Let somebody else say no. Don't tell yourself no. There's until you have that, until somebody tells you, sorry, it's too late, don't think that it's too late, right? So we have Jan, who's one of my heroes here as well, who came back to get her undergraduate degree a little bit later in life, and then went on to get a PhD, and now she's one of the most respected academics here in chemistry, right? And she's one of my heroes. It wasn't too late for Jan. It's not too late for you guys, no matter what you guys are doing, right? I mean, there are some things, it's like, okay, you're 85 years old, and it's like, I'm going to train to be a test pilot. It's like, okay, maybe it's too late, but start it. You never know. There's probably not a whole lot of 85-year-olds that have tried, so let let the Air Force tell you no. But that would be my advice, is don't not start it because you think it's too late. Yeah, you may get the no, and the no is really hard, but then take that no and use that as motivation for doing the next thing. Yes?
Could I just ask you how old you were when you applied for NASA?
Yes, so I was 33 years old when I applied. So the average age for the astronaut classes is 34, and so I was going to be 34 during selection, and it didn't work out, but that's all right. Yeah. Yes?
Does radiation pose a threat to growing plants in space? Because obviously it affects humans quite a bit, but does it affect plants as well?
Absolutely. So radiation does affect plant growth in space. It affects anything that has DNA in it, really, which is all living things, right? So yes, it absolutely affects plant growth and fungal growth and bacterial growth, anything like that. And so a lot of the research is trying to understand how to mitigate the effects of radiation and what organisms can survive well with radiation, and how, as humans, we can shield ourselves and our plants and our fungi and things from that radiation.
So, we often hear about radiation being very destructive, but is there any part of it that's actually in any way increasing growth or, in some way good?
I'm sure there is. I'm not an expert in that field. Again, I think from the point of synthetic biology, we wouldn't have evolution, we wouldn't have all the diversity of life that we have if it weren't for things that make plants and animals and everything mutate, right? So we wouldn't have the diversity of life if it wasn't for things like radiation mutating things, right? So in that case, yes, it's absolutely beneficial. But like anything, the dose makes the poison, right? So a little bit of radiation, a little bit of UV gives you a nice tan. A lot of radiation, a lot of UV gives you skin cancer. So it's a matter of dosage. But again, I'm not an expert, so I'm sure there are other benefits. I just am not aware of them. Yeah.
You say that you've done that on the ISS. There's been a lot of biological experiments. Are there other types of experiments that are going on with different sciences?
Absolutely, and I apologize for that because I'm just really excited about the biology. They've done hundreds and hundreds of amazing experiments. One of the ones that I think are the coolest, other than the biological, so they've looked at flames in space. Which have you guys seen pictures of flames in space? Right, so a normal candle flame goes up, but obviously that's not going to happen on station in microgravity. So it's this ball, literally ball of fire. Lots of physics, lots of engineering experiments. There's some really cool robotics going on right now. Have you guys heard of the Spheres program? So they're basically autonomous robots that are just floating around station that will eventually be able to do their own experiments, which is really cool. Because if you look at an astronaut's timeline of their day, it's 5-minute increments, and they've got to do all these things. And if one thing takes a little bit longer, then they won't get to the other experiment. But if you're just like, hey, robot, can you do that for me? And it's like, yeah, I got this, no problem. But yeah, lots of amazing experiments. So if you go to the NASA website and look at the research on station, so the ISS is a national lab as far as the NASA part of it, the US portion of it. You can look up the list of all the experiments they're doing on station. Yeah.
Is it possible with the radiation, like the extra radiation from like the ISS, that could possibly speed up like biological experiments in terms of like trying to maybe like evolve like a strain or something to something else, like because there would be extra exposure to all this radiation?
So they have done some really cool long-term experiments looking at the microbiota on station. And there are definitely differences. Obviously, they're going to be compounded with both radiation and microgravity and just being isolated from everything else. So they are seeing changes. Again, the radiation one, I'm not an expert in that, so I couldn't tell you the results, but that's absolutely quite possible, yeah. Yeah.
Is there anything you'll do differently applying for the astronaut selection this time?
So is there anything I would do differently applying for this selection cycle? The biggest piece of advice that I got both before I applied and then as I was going through the selection was just be yourself, right? So like I said, I was a part of a bunch of different communities that for people wanting to be astronauts, so astronaut hopefuls, right? And it was really interesting. I'm an ASSO. I hope some of you guys are as well. And it was interesting looking at the people that were applying, and there were some people that's like, said, at 5 years old, I want to be an astronaut, so this is what I'm going to do to become an astronaut. And they started ticking boxes. So they were an engineer, and then they learned to become, they learned to fly, they became a pilot, they learned to scuba dive, they did charity work, and they did all these things. They're like, this is going to make me a really good astronaut candidate. But they weren't doing the things that they loved. They were just doing it because that's what they thought NASA would want. That's not what NASA wants. NASA wants the best and the brightest people who love what they do. So I'm not going to change who I am. I'm just going to keep being me and, awkward, high-fiving scientist, right? That's who I am. So in that regard, no, I won't change what I do. There are some things that I'm doing that I've always wanted to do that now I'm a little bit more motivated to do them, like becoming a pilot. So I'm taking flying lessons, which is really, really fun. But also, it also will help for the next selection cycle. But I will go in with everybody else, so I'll be one of 18,000 again. I don't get any special treatment. So we'll see if I'm still competitive. Like I said, I know how many amazing people are out there. So if I get to get further in the selection again, then it would be an absolute honor. But otherwise, I'm just being my crazy self. Yep.
Do you have to know how to fly to go? Do you have to be a pilot or have pilot training to be a candidate?
No. So you absolutely do not have to know how to fly to be an astronaut candidate. They will teach you how to fly a T-38 jet, which is pretty phenomenal. But the pilot training helps with what they call sort of expeditionary experience. So experience with sort of things that are high risk and potentially fatal if you do something wrong. So that's where the pilot training and the scuba training come into benefit. But then also during your astronaut candidacy training, you will learn to scuba dive in the neutral buoyancy lab, basically with a mock-up of the space station underwater. And you will get to learn how to fly a T-38 jet. So if you already have some of those skills, it's absolutely beneficial, in addition to being really, really fun. Yep, I was gonna say, I will keep answering questions. I don't want to keep people here after, but I will just stay up here and answer questions as long as you guys want me to.
Will NASA be selecting more astronauts like in the future because they've got the two new crew vehicles, and actually the Orion as well?
Yeah, so that's an excellent question. So currently the astronaut corps is about 50 people, and they try to keep it at about 50 people. And so with retirements and things over the course of 4 years, they usually take 8 to 14. But that's since 2011 when when our shuttle travel ended. And so the only way that American astronauts have been able to get up to station for the last nearly a decade is with the Russians with the Soyuz vehicle. And so now, like you said, we've got the 2 commercial crew vehicles with Boeing and SpaceX, and then also Orion, which is sort of NASA's answer to a manned spacecraft. And so there will be more U.S. astronauts going up, and whether they're for longer or shorter missions, but we definitely have the ability to get U.S. astronauts up into space again. So that's, again, the wider community, that's our hope, that there will be more spots for new astronauts, but that's absolutely not a guarantee. We'll see what the U.S. government gives as far as NASA manned space program budget, but that would be, that's a good, it's a good guess that there will probably be more astronauts in the future.
Do you know how long the average astronaut career lasts for?
That's an excellent question. So it's changed throughout the years, obviously from the original Mercury astronauts to through Apollo, through the shuttle era, and to now. So typically 10 to 15 years. So you have 2 years of training. So you come into the program as an astronaut candidate. So for those first 2 years, you're not actually eligible for missions. So you learn space station systems, you learn Russian, you learn how to fly T-38, you learn all the different programs that the manned space program does. And then once you graduate all of those skills, then you get your astronaut pin and you're eligible for missions. But just because you're eligible doesn't mean you get a mission. So typically astronauts have, after they graduate from astronaut candidacy, have a couple years where they're just in the astronaut corps doing things on the ground. Really cool jobs like Capcom, so capsule communicator, where you guys basically get to be the astronaut voice on the ground for the astronauts that are on station. So you're sitting in mission control, and during spacewalks or during normal everyday work, you basically get to be the voice on the ground for the astronauts up there. So it's, as they go through experiments or as they do media events, there's astronauts on the ground that get to do those jobs. And they also get to do jobs, if you're a scientist, you can work in the labs, at Johnson Space Center. So you get to do different things on the ground that are obviously, they're helping things up on station, but you're obviously not working towards a mission. And then once you get assigned a mission, it's usually at least 2 years of mission-specific training. So learning all the experiments that you're going to be running, learning, again, specific space station systems and the systems for whatever vehicle that you're going up with. So in the case of, how it's been since 2011 with the Soyuz, and that sort of thing. And then you have your mission, and then you have basically 6 months to a year where you get to sort of debrief and build your muscles back up again. And then, since 2011, the astronauts are not getting more than 1 or 2 missions. But now, hopefully, again, with the new vehicles, that we should be sending people up multiple times. But typically, astronauts stay in the Corps about 10 to 15 years. Yeah.
How much does the political side of things affect NASA's budgeting and where it directs it to? Because currently, the current government has expressed interest that they want NASA to focus less on outer space travel and more just point their satellites towards the Earth and do more space sciences, which is always important. But that, I think, wouldn't a big part of NASA's kind of appeal and aims be hindered? So how much effect do you think political agendas have?
I'm not going to speak for NASA or the U.S. government, because then we get into real sticky situations. But it absolutely, you can only do what you have budget for. And those budgets do change depending on Congress and the government and that sort of thing. But I can tell you, the scientists and the engineers and the trainers and everybody on the ground at NASA, basically with whatever budget they're given, they're going to do, 110% out of that. Yeah.
If going to space was never an option, what would be your next favorite adventure on Earth?
Oh, going to space was. All right, so if
Let's
anything,
say
let's
let's say we all, as a planet, decided to never send missions into space again.
Yeah.
What would be the next best adventure?
Next best adventure, I reckon bottom of the Marianas Trench. Yeah. If we can't go way up, we're gonna go way down. What's down there? But honestly, the ocean fascinates me on a number of levels. But again, and I'm very biased to biological, so I apologize. But the fact that things can grow under that extreme pressure and extreme darkness is just fascinating to me. And then the geology and the physics of it, and the engineering to try to get vehicles to go down there. So I think that would be the next greatest adventure, is let's explore the depths of our ocean. Or just be a mountain climber, because that would be also pretty cool. But I reckon as far as science and engineering and combining adventure and everything, deep sea exploration would be the next best thing. Awesome. Thank you guys so much. I'm here to stay and chat as you want. Otherwise, whatever you guys are excited about or passionate about, if you want to come talk to me, I'm in biology, so if you just go to the UC webpage and look me up. I'm always happy to talk to students, to mentor students, and hopefully if I don't have answers for you, I can send you to somebody that does have answers. Otherwise, like I said, I'm really excited that you guys are part of the community, and looking forward to where we can take aerospace here in Christchurch.
This talk, sir. So we just have a couple of things. Very lovely wish and a card. If anyone has not signed this, you more than welcome to sign this before this. And
Who drew this, by the way? That's amazing. Well done. Thank you. That's gorgeous.
And we're trying to do a little bit of merch. And so we have a limited edition. We're hoping to do more. So keep you posted.
Awesome. Thank you so much.
Yeah.
Cheers, team.